Hey Internet, Gordon Young with PCWorld here. I know if you're like me, you're glad to just be over this laptop launch cycle. Yes, I'm sick of them too. You probably are as well. We've seen Qualcomm launch Snapdragon X, which is basically ARM on Windows. We've seen AMD bring Ryzen AI 300 to laptops, thin and light laptops, and now we are finally seeing Intel show off its long-awaited Lunar Lake CPU, basically the savior of x86 for the PC. I know that sounds dramatic, but people really do expect this to save the PC from the onslaught of ARM CPUs, from Apple, from Qualcomm, from everyone, basically. And a lot of people do think this is going to be Intel's last chance to save it. And I'm not going to be too dramatic, but I'm going to try to attempt to answer that at the end, because the only thing that matters is result charts at the end of the slide deck. You can go ahead and go all the way to the end, skip all the performance testing I've done because you've already kept up on all the performance testing. You know what to expect. You know it's not going to change that much. You just want to know, is Lunar Lake going to change the performance paradigm? And I got news for you. It probably does. But you know what? That's at the end. For now, let's kick this off where we start everything. I'm going to try to jam through these charts as fast as I can because there are an awful lot of charts to get through. Not as much on the efficiency as I've done on Snapdragon because there simply were no options because a lot of software simply does not run on Snapdragon parts. But let's go ahead and kick this off. Let's kick this off where we started everything else, which is the stats of all the laptops. Of course, you cannot look at laptops without looking at you cannot look at laptop CPUs without looking at laptops themselves. So we are looking at the specs of many of the laptops that we're looking at. The two newcomers here are the Dell XPS 139350. Both of them are Core Ultra 200 series. One is Core Ultra 7 258V, which is in that XPS 13. The other one in the Zenbook S14 is running a Core Ultra 9 288V. And that is basically running the higher clocked, higher TDP version of the Core Ultra 200 series. They are both 8-core CPUs. You can see the rest of the specs here. They do match up similarly with the other laptops, 32 gigs of RAM. The SSDs are a little bit smaller on the Dell, but for the most part, they are very, very similar. Cost is probably similar once all the prices wash out, but and the size and weight, I would consider all of these Ultrabooks because they are really, for the most part, big Ultrabooks. But let's go on with performance because that's what you want to know, because that's what does matter. Performance matters to PC users. So let's kick this off with Cinebench 2024. And this is basically results that I've generated myself or results that I've generated results that I've obtained from a third party. In this case, the MacBook Pro 14, the MacBook Pro 15 are from our sister site, Mac World, but I did want to include that because it does matter a little bit. Most of the benchmarks you are not going to see M3 on here, but it's fun to see this in Cinebench and a couple benchmarks because they do still show up. They are relevant here in this space. So let's kick this off though with Cinebench 2024. This is multi-threaded performance, and we are looking at the bottom here in the dark blue. All the dark blue laptops are basically Intel laptops. You are seeing the Core Ultra 7, Core Ultra 9 200 series, and the 100 series. And you can see we are getting a very nice uplift in performance when you're looking at that performance of the, say, Core Ultra 9 288V. When you're looking at all-core performance, you're looking at the Core Ultra 9 288V outperform the Core Ultra 7 258V. So basically that is a slightly lower clock version, slightly lower TDP on that by about 12.5%. And when you're looking at it from Meteor Lake versus Lunar Lake, 8-core again versus 16 cores? Let's make sure I got that right. Yeah, we're looking at basically 16 cores for that Zenbook 14 OLED with the Meteor Lake versus the 8 cores of that Zenbook 14 S14 with that Core Ultra 9 288V. You're looking at about 10%. So honestly, yeah, it does not win any battles here. I don't think anybody expected Lunar Lake to outgun Meteor Lake, especially because Meteor Lake does simply have more cores than, frankly, everyone here. But the cores are not the most performative all the time, and you can actually see that despite the Zenbook S14 OLED having 16 cores, it's actually being outperformed by the Core Ultra Lunar Lake laptop, the Core Ultra 9, by a decent 10%. So that's something to be said. But when we're looking, probably what Intel cares about the most is about what's in Team Red. So Asus Zenbook S16 with that Ryzen AI 9 HX370 scores 982 versus 683 of that Meteor Lake and 620 for that Core Ultra 9. Remember, that is 8 core versus 12 cores in that Ryzen AI 9 HX. And when you're looking at Surface laptop with Snapdragon X, that's 12 cores again versus 8 cores in the Core Ultra 9 288. You're looking at 869 versus 620. So a decent win there for both of the higher core count Snapdragon and Ryzen AI parts. But honestly, I say that's not that bad when you're looking at 12 cores versus 8 cores or 16 cores versus 8 cores. I say that's not bad at all. But let's move on to something that's a little more relevant, because obviously it's weird because we have different core counts. I mean, they also, by the way, the Ryzen AI and the Snapdragon X Elite also kind of beat the MacBook Pro and the MacBook Air pretty badly here because it simply has more cores. There are more cores available on the Mac, of course. But let's kick on to Cinebench single-threaded performance. And that's where you're only looking at a single core performance, single thread performance of these CPUs. When you're looking at only one core, one thread, so we eliminate the fact that one CPU has more cores, I would say we're looking pretty good here for Lunar Lake, because when you're looking at Meteor Lake, the Ultra 9 285V, 258V, got to get that right. That has a score of 122 versus 104, giving it about a, 17% performance advantage over Meteor Lake. And when you're looking at when you're looking at Core Ultra 9 versus Core Ultra 7, that both 200 series, but basically you're looking at spending a little more money on an Ultra 9 versus an Ultra 7 for the 200 series. You're looking at only about 2.5%, so not a big deal there. There are definitely differences in how the laptops are tuned by the OEMs, but for the most part, I would say pretty boring here, and I wouldn't care too much about this between the Ultra 9 and the Ultra 7, but the thing that does matter is the Lunar Lake does actually, I would say it handily outguns the Meteor Lake equipped laptop by a healthy bit. And also I did include the older Framework 13 and the HP Spectre 13.5 because they both have Core i7 13th gen CPUs. Those are basically 100 scores in 2024 Cinebench for single-threaded performance. That basically means the Core Ultra 7 is about 22% faster performance than the 13th gen, that Raptor Cove cores, and it's also about 25% faster for the Core Ultra 9 and the 288V. And of course, when you're looking at the Apple laptops, they're actually a decent bit ahead of them. But when you're looking at, say, let's look at Zenbook S16, because that's what does matter to Intel. They don't want you buying AMD. They want you to buy Intel. They don't care if you buy any Intel as long as it's an Intel. You're looking at 113 versus 122, or roughly about an 8% improvement for Lunar Lake over Ryzen AI HX370. So I wouldn't describe that as everybody would like to say that is an improvement in IPC. I would say that's overstating it a little bit, but definitely there's an improvement in single-threaded performance for the Lunar Lake cores over the Ryzen AI cores. I would definitely say that. And I would say it's fairly even when you're looking at Snapdragon X Elite. So let's keep going, though. Let's keep going. This is Blender. This is Barbershop. This is basically a rendering workload like Cinebench. It's not something a lot of people are going to do on a thin and light laptop, but arguably as you're getting up to these high core count CPUs, it's something you may want to do. I'm still not so sure I'd want to do that on a thin and light laptop. I would still want to probably push it over to a performance content creation laptop. At the same time, we're seeing Meteor Lake lose handily to Lunar Lake. Lunar Lake is giving you about a 9% improvement. Interestingly, this is the weird thing. Oh, actually, no, this is not the weird thing. You're actually seeing about a 9% improvement for Ultra 9 versus Ultra 7 for that 200 series. And when you're looking at just pure core count here, because this this performance benchmark is basically it is an all-core, multi-threaded benchmark where you're running all those cores really hard, and in the end, it's going to be really hard to beat a 12-core higher clock Zenbook S16 with, again, 12 cores, 24 threads with a score of 1458 versus a score of 2884. That's basically giving that Ryzen AI 9 HX370 an advantage of almost 50% over the new Lunar Lake. Yes, of course, it is 24 threads versus a total of 8 threads, but still, if you are going to really be looking at doing, heavily multi-threaded tasks, I'm going to say you're probably going to want to look at CPUs with more cores in them. For Intel today, Lunar Lake is not that chip. Maybe that shows up with Lunar Lake. There may be Arrow Lake H. There may be a CPUs that come from Intel that have more cores in them. But for now, I would say this is not going to be the chip for you if you want all those cores. You're going to probably want an S16, frankly. All right, let's keep going though, right? Next up is Handbrake. This is basically an all-core encode. Again, you're going to want the CPU with the most cores. By the way, the CPU with the best score here is that Zenbook S16 again, a Ryzen AI 9 HX370 again with 24 threads. 12 cores is beating everybody, and you're looking at it outgunning the Ultra 9 288V by almost 23%, right? So that is a very decent win. And when you're looking at, although I guess the moral win for Lunar Lake is despite it only having 8 cores, it is still outgunning Meteor Lake by almost, it's only losing to Meteor Lake by about 7%, which is not bad because Meteor Lake, remember, has 16 cores versus 8 cores. And that's, there's more threads. There's 22 threads on that Meteor Lake laptop too versus the 8 cores and 8 threads of that Lunar Lake laptop. So that is a good moral victory for Intel here for Lunar Lake. But still, if you want more cores, you really need all those cores to do all these heavy lifting. You're going to want to look at probably a Zenbook S16 or something with a Ryzen AI 9 HX370. Something with more cores in it. Frankly, even though this doesn't show the best for Surface and Snapdragon X, it actually does fairly well as well. But still, I would say definitely Ryzen AI 9 HX370 is the chip you're going to want if you want all cores. Keep going, though. Keep going, Gordon. You got to push on to. This is a synthetic benchmark. It's made by Babco. It's basically a bunch of benchmarks that Babco has created to test productivity, creativity, responsiveness, and then it gives you an overall score. The overall winner, surprise, 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 is actually that XPS 13 with that Core Ultra 7 258V, and it actually beats the Core 9 in the S14 with the Core the Ultra. God, these names are going to kill me. The Core Ultra 9 288V. It beats that Ultra 9 by about 4.5%, and it'll beat the Meteor Lake by about 5%. And it's also outgunning that Ryzen AI by about 6.5%. So not huge wins overall, but still the solid wins for Lunar Lake. This test, though, is generally lightly multi-threaded, and you can see Intel has put a lot of work into redoing the cores on the Lunar Lake. They've designed them from the ground up to be, to give them the best performance out of x86 that they can, best efficiency out of them, and it looks like they're doing it pretty well because they're actually outperforming both the Ultra 9 Lunar Lake, the Meteor Lake. It's also outgunning that Surface Laptop 7. Yes, I labeled it Surface Laptop 13. God knows why. But it's outgunning that Surface Laptop 7 with that 12-core Snapdragon X Elite in there. So that is something we said. Of course, I will say CrossMark is not optimized for Snapdragon X Elite. So that's probably the reason why it's losing badly here. But not as bad as you'd think it would. Let's keep going, though. Let's keep going. This is a popular one. This is a Geekbench 6.3 Okay, Gordon, what do we have after Babco CrossMark? Okay, the next one's fun because everybody recognizes it. It is Geekbench 6.3. The overall winner for Intel chips is the, let's make sure I got this right, I keep on getting it wrong, is the chip with the most cores, and that is the Zenbook 14 OLED with that Core Ultra 7 155H with Meteor Lake. 16 cores, 22 threads, no joke, it's going to win here with a score of 12,680. Number two, though, is not that bad because you're looking at only 8 cores, and that Core Ultra 7 258V is 11,232, which makes no sense because why isn't the Core Ultra 9 winning this? Because it's a higher clock part, it's got higher TDP. I'm not so sure. It could come down to OEM tuning. It could come down to many things that's going on. Drivers, OEM tuning on new laptops. Who knows? But overall, the Dell XPS 13 ekes out a very slight win over the Core Ultra 9 288V, which is a little bizarre to me. But both of them do not beat the Ryzen AI 9 HX370, which does really well for x86. The overall winner, though, is the Snapdragon X Elite X1E 80-100 in the Surface Laptop 7 with a score of 14,714 because, hey, those Snapdragon cores, Snapdragon X Elite cores are no joke, right? They are really good cores, and it's doing really well here. Again, Geekbench obviously is probably well optimized for Surface Laptop 7 and Snapdragon X Elite, and you are seeing it on top of everything. And of course, the moral win for Intel is like, hey, look, our Core Ultra 7 258V in an XPS 13, which is a smaller laptop, is actually doing pretty well against that MacBook Air 15. That is a slightly bigger laptop. Yes, it is fanless, but you're looking at both of those with a score of 11,000-ish, right? 11,936 for the MacBook versus 11,232. So pretty close. And I would say Intel's probably pretty happy with that score because the MacBook has been the one to beat in a lot of these performance runs. But let's kick it over to single core performance because single core performance does matter. Single core matters because now you don't have to worry about like this CPU has 12 cores, this one has 16 cores, blah, 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 blah. Let's only look at the performance of a single core. So what do we got here? What do we got? The overall winner is the MacBook Air 15 M3 with a score of 3154. No joke. You spend the most amount of money to make your chips, you come out pretty well. Apple's doing really well here in Geekbench 6.3 with that score in single core performance. But honestly, when you're looking at the rest, Lunar Lake is not looking bad. Now, of course, you want to compare it to the previous generation. You're looking at Meteor Lake, which has a score of 2397 versus 2769 for Core Ultra 258V and 2783 for Core Ultra 9 288V. So those are a good clip, 15 to 13% faster than that Meteor Lake over previous gen parts. And then if you're looking at Snapdragon X Elite and you're looking at Zenbook S16, they're damn near even. So I would say they are pretty much tied. Yes, they are slightly faster for Ryzen and for Snapdragon, but this is basically the same performance score. And for some reason, everybody cares about Geekbench. So I would say this is a decent win for Lunar Lake and for Intel second generation series parts. Okay, up next is OpenCL performance. This is basically looking at the performance of the GPU cores in these laptops. And so the highest score belongs to the Ultra 7 155H. Again, that could come down to drivers, could come down to OEM tuning, could come down to the fact that that is a pretty hot chip on that laptop. That might be the reason why. Up next, though, is your Ryzen AI 9 HX370. Of course, you probably want to know how Lunar Lake does. And they actually do pretty well, especially when you compare them to the MacBook, because they're pretty much dead even with the MacBook Air 15, with the Ultra 9, smack dead even with it. And then margin of error probably for the Core Ultra 7. So I would say pretty good there. And they both also handily beat the Snapdragon X Elite X1E80 in Geekbench OpenCL. So if that's what floats your boat, go to it. Let's keep going, though. All right, up next is something that does matter because it is something that everybody uses, and that is Adobe Photoshop 25.9. To test this, we are using Geekbench 1.0.0. And basically, I would say these scores are all very similar, although I would say for the Intel parts, the surprise win goes to that Core Ultra 7 258V in the XPS 13, and where it sleeks out a slight edge against that Zenbook S14. Not a huge win, but it definitely does kind of come in slightly in front of that Ultra 9 200 series. And then both of those also skid in front of the Core Ultra Meteor Lake. So definitely both of those are ahead of the older Intel part. And AMD does pretty well here with that Ryzen AI HX 370 with a score of 7432, where it's actually outperforming the XPS 13 by a decent bit. Also, both of them also will outperform the Surface Laptop 7 with the Snapdragon X Elite. So, you know, overall, Lunar Lake does pretty well here. It doesn't adjudicate itself totally against the Snapdragon and the Ryzen, but I would say it does fairly well against what it really has to beat, which is Team Red and Team Qualcomm, because it really does have to beat those at the store. And it looks like it's got a good argument for why you might want to buy Lunar Lake over Snapdragon X or Ryzen AI, because when you're basically gunning very similar performance in something that's very popular, most people are probably not going to care that much. But let's keep going. All right, let's dig down into Adobe Photoshop. So there are some subscores we can look at. These are colored differently because the laptops are actually in different categories. They stand alone on their own. The overall winner is that Zenbook S16 with that Ryzen AI 9 HX 370. 75 versus 67 for filter score is pretty decent. Although the Ultra 7 with the Ultra 7 258V does slightly outgun that Ryzen AI 9 HX 370 by 1 point. Not a big difference. Again, I would say these are pretty close in performance. I don't think anybody's going to care too much about this, but basically your performance in Photoshop, which is a good win for AMD too, because Photoshop does matter. You want to look good in Photoshop. A lot of people use Photoshop and they are looking really good in performance, and they're doing pretty well in filter score and general score. Although generally, the performance for filter score goes to the Ryzen AI, right? Because they've got a bigger bar for the filter score, whereas they're more even when you're looking at general score. And Meteor Lake is definitely a good clip behind both the newer Lunar Lake and the Ryzen AI 300 chips. All right, if you want to dive down into the Photoshop scores, I'm just going to show them. I don't think it really matters too much here because I would say they're fairly close. Although Meteor Lake is, I think, clearly not doing the best. Depth of wide angle and filter performance is losing handily. It's also losing handily in lens correction for Meteor Lake. Also reduced noise. A lot of that performance is showing up in hurting Meteor Lake's performance, whereas in Lunar Lake, they pull up much, much closer to Ryzen AI 9 HX 370. So they are doing pretty well there in performance. And of course, Snapdragon X Elite, not bad overall. They also beat Meteor Lake by a decent margin. But I would say when you're looking at Meteor Lake and Lunar Lake and Ryzen AI, you can sort of pick and choose your wins as to which is better here. So go ahead and look at the filters you use the most and decide that's what you care about and go, okay, this is what I use the most. This is what I care about. Buy that laptop, buy that SoC. Same thing here with general performance. Again, same thing, whereas, you want the laptop that's giving you the bigger bars. If the Meteor Lake is giving you a bigger bar, and generally you want a lower bar here is better because smaller bar is better. You want that. But in overall, for the most part, Snapdragon does pretty well here. Ryzen AI does pretty well here. And to be honest, Lunar Lake does pretty well here too. I would say there's no huge clear-cut wins here. There are some wins in each category. Pick and choose what works best for you folks. That's what you should do. All right, up next is Procyon Office. That is a very lightly threaded benchmark. It basically uses Procyon. You use Procyon to run through Office running Word, Excel, PowerPoint, and Outlook, running them through all these different tasks. The bigger bar is better. The bigger bar means more performance in Word, Excel, PowerPoint, and Outlook. And the winner here overall, surprise, surprise, is that Dell XPS 13. I don't know why that is, but simply it's the bigger bar overall. It's outperforming Ryzen AI. It is outperforming the Snapdragon. It is outperforming Ultra 9 Series 2. It is outperforming Meteor Lake by a very, very decent margin. You're looking at 15% over Ryzen AI, and you're looking at 12% over Snapdragon X Elite. So that is a decent win for that XPS. And I don't know if that's, again, drivers, how the laptop's configured. Who knows? But the win here goes to Dell. Number two, I'd say, probably goes to what? Number two is, we're going to give it to Snapdragon. We're going to give it to Surface Laptop and Snapdragon, where it's fairly close, but I would say it's awfully close to that Ultra 9 288V in the S14. It just slightly outperforms it by a little bit, and it's pretty much a dead tie between the Ultra 9 and the Ryzen 9. Interestingly, with the Snapdragon X Elite outgunning both of them by a bit, and of course that older generation Meteor Lake just looking kind of old here, I would say, and we're seeing the age of this older generation, and you look about it, when you think about it, it's barely a year old now, which is kind of crazy. So the fact that it's being outgunned by a new Intel chip, barely a year newer than it, is kind of crazy. So who knows? The world of CPUs. Let's keep going, though, because there's a lot. Next up, browsing stuff. And I know you, Gordon, why do you keep running this light stuff? Office, you're running Geekbench, you're running Chrome, you're running browsing performance. Well, because I think, honestly, when you're looking at this class of laptop, when you're looking at an S16, you're looking at a Surface Laptop 7, you're looking at an XPS 13, you're looking at a Zenbook 14 OLED. These are thin and light laptops. Yes, you can do more on them than you could on a laptop 5-6 years ago, but they are, for the most part, thin and light laptops, and I don't think people are really going to be looking at doing content creation tasks on these. And so that's why I really looked at lighter tasks. And again, this is why I'm using browsing tasks here. And again, I would say, would I care if I had a Ryzen, a Snapdragon, or a Core Ultra 100, or frankly even 200 here? Probably not. Honestly, I think it isn't going to matter that much. They're all pretty close. And yes, there is a winner. The actual winner is the Ryzen AI 9 HX370. But let's face it, it's within the margin of error for that Ultra 7 258V. It's within the margin of error for the Ultra 9 288V, right? Who cares, basically? Who cares if you can do browsing? It doesn't matter that much. This next test, though, is a little bit of a test. A lot of people will think, oh, you know what? If I'm only doing Excel, all I need is a thin line laptop. I need an Ultrabook. I don't need a laptop where I can really push all that high core count. Well, I beg to differ. More cores actually do matter if you're using Excel in a matter that matters a lot, because this is a benchmark created by an esports competitor. It is a real benchmark because it's based on reality, but it is also something that runs faster if you throw more RAM at it. It is something that runs faster if you throw more cores at it. And the winner here overall is the Zenbook S16 with that Ryzen AI 9 HX370. Look, 12 cores gives you more performance than the Snapdragon X Elite, because it doesn't have hyperthreading, it doesn't have SMT, and it comes out a decent bit faster than that Snapdragon. And also, but again, there is a moral victory for Intel, because I would have expected the 8-core Ultra 9 288V and the 8-core Ultra 7 258V to lose handily here by much, much larger margin, but it's actually pretty close. It is much, much closer than I expected, where Snapdragon is basically 10% slower and Ryzen AI is only 20% faster than it. So I'm actually quite surprised. I really thought we would get it. It would get beaten pretty bloody by this, but it's not that bad. Not as bad as I thought. And Meteor Lake does pretty well, of course, because it has 16 cores. So yes, more cores do matter. And if you were to throw more cores with a higher TDP laptop, it'll do pretty well as well. So it does matter here. But you do want to see the performance in this benchmark here for Lunar Lake versus Meteor Lake. And I would say, again, not bad for Lunar Lake, but if you want more performance, you probably want, and especially if you want it for more cores, you're going to want a Meteor Lake laptop with more cores in it, or even, frankly, an older Raptor Lake laptop with more cores and a higher TDP in it, or even a Ryzen AI, because Lunar Lake with its fewer core count it's just simply not going to do the same magic that you're going to get out of it. And again, I would say the same thing for Premiere Pro, because that's what I'm running next. Most people would never run Premiere Pro on a thin and light laptop. We're getting to the point where the graphics on thin and lights are actually doing really, really well, to the point where you could actually run Premiere Pro on a thin and light laptop. So let's look at what we're going to get here. And I would say basically we're looking at dead even performance between both of the Lunar Lake laptops and the Ryzen AI laptops. It's a big fat zero for the Snapdragon X Elite because it doesn't run on Windows on ARM. That's not Intel's or AMD's fault. That is, frankly, Qualcomm's problem. That's Microsoft's problem. But they are pretty much dead even here. And lower is worse here. And, of course, you see that score for Premiere Pro, even though the Core Ultra 7 155H has more cores, it actually is doing worse here. Okay? Let's keep going because we got to still go through a few more charts. We're into graphics now. We're into graphics. We're out of the application performance, but you're going to want to see the chart at the end. Please stick around for that chart at the end because I think that is going to be the one chart you want to see at the end. You can skip to the end and find out what the performance in efficiency is, but let's check this out. This is TimeSpy Graphics. The overall winner is Core Ultra 9 288V. It has that brand new XE2 cores, basically what we're going to see in the new cores in the 200 series parts. And both the 200 series parts are handily outgunning the Core Ultra 155H by a decent margin. And they're also both beating the Ryzen AI HX370 and the Ryzen and the Snapdragon X Elite in the Surface Laptop 7. So nice wins for the Intel parts here in the synthetic graphics here. I know people don't believe in 3D Mark. They don't believe in 3D Mark in TimeSpy Graphics, but I think it's actually a useful synthetic benchmark because it doesn't change that much. You can come back to this benchmark in 2 years, and the score is probably not going to change one bit. So it's a useful benchmark and to look at as a reference point. This is Steel Nomad, and it's basically a brand new graphics benchmark that is optimized for Snapdragon X Elite for ARM parts. And even though it's optimized, it doesn't help them that much because they still get beaten pretty badly by Intel and Ryzen. And frankly, it's dead even between Ryzen, between Series 200 and 100 for Core Ultra. But you're looking at a 60% better performance for Core Ultra 9 288V over that Snapdragon X Elite X1E 8100. So that is a bad loss for that Snapdragon X Elite part. And that's probably what we've seen for the most part overall, that they simply can't compete in the graphics when you're looking at Core Ultra versus Snapdragon X Elite. The graphics performance is just not there on Windows x86 performance. It just ain't there. And this is an optimized app for ARM, right? So let's keep going. Next thing is an actual game. This is Cyberpunk. We'll just look at the performance in the games. The overall winner is Zenbook S16 with that Ryzen AI 9 HX370, but let's face it, that's within margin of error for the Core Ultra 9 288V. And they both actually give a nice advantage over the Core Ultra 7 258V, which has that lower clock, lower TDP graphics cores in them. And of course, the 155H, despite it having a higher OpenCL performance, did not matter to Cyberpunk as an actual game. It did not care, and it still liked the Ultra 200 and it liked the Ryzen AI 300 over those newer AMD and Intel parts. So keep going, though. Up next, set up the Tomb Raider. It's another game. It's an older game. Running this at 1920 by 1080 using the low preset. The big win, of course, goes to Zenbook at 16 with Ryzen AI 9 HX370, 64 frames a second versus Core Ultra 7 in the XPS 13. Core Ultra 7 258V with 51.7 frames a second. You're probably wondering why the XPS 13 again is outgunning that Zenbook S14 despite that. S14 having the Ultra 9 288V in it. That is a faster chip technically on paper than the 258V, but the actual Ultra 7 258V is outperforming it. Could be drivers, could be laptop configuration, could be how the laptop is built, could be laptop cooling. It's not really clear to me, but the winner here is XPS 13, even though it's a smaller laptop. They weigh about the same though, so maybe it is the cooling. But overall, the win goes to Ryzen AI 9. They actually kind of tie dead even with the Core Ultra 7 155H, the Meteor Lake laptop, so fairly even. But again, we're seeing that Snapdragon X Elite X1E 80-100 lose handily with a score of 30 versus 51 and 46 for Lunar Lake and 64 for Ryzen AI 9 HX370. So that's just simply been not the greatest story of Snapdragon X Elite. Gaming has been what you want to buy it for, and it just simply hasn't won any contest that I've seen. Next up, again, we reinforce that score. This is Tom Clancy's Rainbow Six Siege, running at 1920 by 1080 using the medium preset. The winner here is the Zenbook S16, again, Ryzen AI 9 HX370. I know Intel says, hey, we win a lot of games when we run up against HX370. Well, maybe you do, but you're not winning this one in my book. The overall winner is the Zenbook S16 with that Ryzen AI 9 at 154 versus 93 for the Core Ultra 9 288V and 127 for the Core Ultra 7 155H. That is, of course, Meteor Lake, where it's just simply outperforming it. I actually think I would have gotten a better performance out of the XPS 13 with that Core Ultra 7, but for some reason it was not generating a score. I don't know if it's a problem with Tom Clancy's Rainbow Six Siege, whether that's a driver issue, but it looked very smooth to me, but it was not generating a score, so I had to give it a did not finish, no score there. And I will say, of course, Snapdragon X Elite, which Intel would like to rub it in Qualcomm's nose, not doing well there at 38 frames a second. And that is with a Snapdragon X Elite X1E 80-100, where it's, again, not winning any contest. Basically, Ryzen coming out on top, a Meteor Lake coming out second, Lunar Lake in third, and Snapdragon X Elite in a very distant fourth place. Okay, up next is probably the only thing you care about, though, and that is efficiency, because Intel has made some very, very bold claims that Lunar Lake, the Core Ultra 200 series, would be the most efficient x86 core it has ever designed. In fact, it would change the perception of what people think you can squeeze out of an x86 laptop in efficiency, because we know the world has told us that ever since we saw the first M1 MacBook with a ARM chip inside of it, performance on ARM simply outguns x86, and x86 simply cannot compare to what ARM can do in battery efficiency, in power efficiency. So Intel went back to the drawing boards. They redesigned everything. They threw out hyper-threading. They threw out a lot of the cores. They redesigned it. They moved the some of the cache into the actual package itself. They did a lot of redesign to make this the most efficient x86 cores the world has ever seen. The problem is, how do you get to that? I've been trying to find out whether that's true or not for weeks and weeks and weeks now. I've tried different laptops. I've tried different laptops with different battery sizes, laptops with different panels. I've turned off the external panel. I've tried every single thing I can, and I've not been able to get to the bottom of, well, is this going to be more efficient or not? So I think the only way you can do this, and the only real world way you can do this, is to use the exact same laptop, using the exact same specs, using as close to the same hardware inside as you can, to generate that performance score. Okay, so to do that, I relied on Dell to loan me 3 matching laptops. These are basically 3 matching XPS 13 laptops. They are not exactly the same, but they are pretty damn close. We're going to look at another picture of the XPS 13. The XPS 13, here you go, right here. That's a top-down view of it. Quite a beautiful laptop. I really like it myself. It is really, really compact. These are the specs of the laptop, although I do have the model number of the Qualcomm laptop incorrect. That is the XPS 13 9345. So we have an XPS 13 9350, a 9345, and a 9340. They are all running Windows 11, although the XPS 13 9340 running Meteor Lake, of course, there's a key component here, is running Windows 11 Home. That one is running a Core Ultra 7 155H. The next laptop is running a Qualcomm X Elite X1E-80-100. And finally, we are running an Intel Core Ultra 7 255V CPU. That is, of course, Lunar Lake. So that is an 8-core CPU. That's 4 performance cores, 4 efficiency cores, up against 12 cores of the XPS 13 9345, up against the 22 threads or 16 cores of the Dell XPS 13 9340. And, by the way, they have the exact same panels. They all have the exact same Sharp SHP 1593 panels on all 3 of them. They all have LPDDR5, although they are different clocks because Lunar Lake can run 8533. The Qualcomm X Elite can run 8488, and the Meteor Lake will run 7467. They are, of course, all LPDDR5, though. They are all 3 running 512 gig Gen 4 SSDs, although 2 of these are running WD SSDs, with the third one running the Micron SSD. And they're all running the same webcam. They are running 55 watt-hour spec batteries. They are all the same weight. They are running the same chassis. They are all running Wi-Fi 7. They are running 2 Thunderbolt 4 ports. And what else? Oh, so the same screen. They don't have touch. None of these laptops have touch. They're also all running 16 gigs of memory. So basically, 3 different CPUs, 16 gigs of RAM, 512 gigs of storage, same 1920 by 1200 non-touch panels. These are IPS panels, and we are running 55 watt-hour batteries on all of these. The prices differ a little bit, but obviously Meteor Lake and Lunar Lake are the same, and it's a little cheaper to get Snapdragon X Elite, interestingly. But otherwise, these are the exact same laptops. Same power bricks. I did use them with the power bricks that came out of the box. But as far as I could tell, you would not be able to tell the difference between any of these laptops if you look at them, because they look all exactly the same. So, to find out how to run down the battery test, there's many ways you can do that. You could run the battery test. You can run it down by doing a video rundown test. I know a lot of people have problems with that because they think that's not realistic, because that is an awful long time to be running a video on a laptop. I agree. I did not actually do that. I did leave the Wi-Fi on, but I did not connect it to an actual access point. So it was on, but not connected to an access point. So let's, there's also other benchmarks. I know you've seen this box. You can look at the benchmarks that I've done where I'm actually browsing on different laptops using the same keyboard and mouse on all of them. I wanted to do that here, but I just simply didn't have time, because it would take an immense amount of time to set up all 3 of these laptops and get them up and running and do it enough times to where it would matter, because I couldn't just simply do this 1 or 2 times. I had to do this multiple times to make sure I had repeatable results on all these laptops, because in order to get repeatable results, you have to run the same benchmark over and over and over again. So let's look at the first result. So this is UL Procyon Office 365, and this is basically using Office 365 running Excel, PowerPoint, Outlook, Word. It's running all 4 popular Excel running all 4 popular applications, and then it's running those at 200 nits, so all the screens are locked to the same brightness. They are all set to not change the brightness in any of the panels, and they are all set to dim the brightness at 20%, so they would all change the brightness at the same level. So some of them, for some reason, would have default 30%. I set them all to 20%, so they all dimmed at 20%. So my results are, for the light blue, that is Meteor Lake Core Ultra 7 155H, and that is 956 minutes. And that loses handily to the Snapdragon X Elite X1E-80-100 at 1168 minutes. So that's kind of that disparity that we've seen before, where you're seeing that x86 Meteor Lake, is a decent chip for power efficiency. It could not hold a candle to Snapdragon X Elite, right? Because you're looking at, you're looking at 1,168 seconds versus 956. It's a decent amount. Is it a decent amount for everyone to change their mind? I don't know, but I would say it's enough that it may sway some people. And it definitely is enough to sway somebody to say, well, I can't say that's the winner, because there's no way I'm going to say Meteor Lake is more efficient than a Snapdragon X Elite. And I know you're going, where's Team Red? Well, I don't have an XPS 13 with the same chassis, battery, and all that stuff, unfortunately. So I decided to leave it out because I wanted to look at the exact same chassis in all of these laptops. So the actual winner is that bar, that longer blue bar, which is the Core Ultra 756V. That is at Series 200 Lunar Lake at 1,253 minutes. So that's basically a decent 7% better efficiency than Snapdragon X, and a decent 31% more efficiency than Meteor Lake. So again, that is nothing to sneeze at. When you're looking at 31% more efficiency than Meteor Lake for Lunar Lake, that is pretty good. 7%, I would say it's pretty close. But when you're going out and you're telling somebody I won, winner is saying, I got a bigger bar. And I will say this was, again, running at 200 nits. This is running the UL Procyon Office 365 benchmark. The battery, the screen brightness did not change. And this is also run at the balanced power setting for these laptops. So that does matter, because these laptops, it will change the battery performance based on what you're running the power mode on. So let's click over to one more test, because remember, this is multiple times of running the same benchmark. So of course, all the results you're seeing here are in balance mode in Windows 11. There is a way to save more power, and that is selecting power efficiency. And I do that next, but I do want to let you know the reason why you're probably not going to see a lot of efficiency rundown numbers this week is because it takes forever to run these laptops down. It takes me 21 hours just to run down the Core Ultra 7 256V in the XPS 13 laptop. It takes forever. And if you're going to do that multiple times in order to get a repeatable result, you're looking at eating up the entire week just to get usable results in your testing. So that's probably the reason why you're not going to see a huge amount of efficiency testing. If somebody does it, I will be impressed, because that is a lot of testing. I don't know how you did it, but it is inhuman. But let's look at the performance when we click over to best efficiency, because I want to know too, because that does matter a little bit, although I don't think a lot of people are going to do that. Most people, if you're like me, if you're like most people at a company, you unplug the laptop from the wall, you just leave it. You leave it at that and you go. Okay, so this is balanced. Let's look at best efficiency. And you can actually see we close up a little bit. Before we previously got not much of a change between Snapdragon X Elite and Core Ultra 7 256V, basically 7% difference. Not a difference, but the moral win is there for Intel. They are outperforming their old foe ARM with an x86 chip by a very decent 7% in efficiency, using the exact same panel, using the exact same battery, using the same amount of RAM, the same amount of storage, the same SSD size. There's just so many things out of the same chassis, same vendor, and pretty much about as close as you can get on day one as to getting actual efficiency results. And that is to be able to say at Intel headquarters on Lunar Lake launch day, can we say we beat Snapdragon X Elite in their home field? And that is efficiency. And I think Intel can look at the results and they can say, yes, we have, because look, we got a better score, and these are the exact same laptops. So congrats to you, Intel, for doing that. But when we're looking at best efficiency, we see how it actually closes up a little bit more. Before it was 31% for Lunar Lake over Meteor Lake, and now we're looking at basically closing up to about 26%. So it does close up that gap a little bit on Meteor Lake, although still you're looking at 26% to 31% performance efficiency difference. And that's exact like-for-like panel, battery, RAM. That's still probably enough to sway some people to maybe want to go ahead and buy a Lunar Lake laptop instead of a Meteor Lake laptop. So, okay, so how am I going to sum this up, Internet? Well, there is no one perfect CPU. There is no one perfect laptop. There is no one perfect chip you can buy for everything. So let's sum it up into what's best for what purpose. If you're looking for something that's going to give you probably the best multi-core performance, I'm going to generally say AMD. Ryzen AI 300 is just simply going to give you more multi-core performance. Ryzen AI 300 just simply outguns Lunar Lake. It outguns Meteor Lake most of the time. It outguns Snapdragon most of the time. And you're going to want to go with Team Red for all-out, all-core performance. And some of that also pays off into lightly threaded performance as well. If you're looking at lightly threaded performance, I would say actually back that up. If you're looking at also heavily multi-threaded performance, but also maybe give you decent multi-core performance, Team Red and Team Qualcomm actually do that pretty well. Snapdragon and Meteor Lake don't do horribly, but overall, if you were to look at the bulk of all the wins, I would say that's going to go to Team Red and Team Qualcomm. Team Blue doesn't do bad here, but where Team Blue does pretty well, I would say, is obviously efficiency. That's probably what matters again, as I was saying. This is what Intel has been working on for the last year, and they've been wanting to show this off, to say that, hey, we can do it. We did it. We did it. We actually are beating Qualcomm where it matters, and that is efficiency. So that matters to them, and I think they're happy with that. But I also do think that there are some decent wins for Lunar Lake when you're looking at lightly threaded performance, and you simply want really good efficiency. You want lightly threaded performance, and you basically want, frankly, you want a MacBook for PCs, but with the fidelity that you can run every single Windows application, because we know you cannot do that with Snapdragon. There's just simply a lot of things that do not run on Snapdragon, on Qualcomm, that you can run on Lunar Lake now, and you will not give up any of that. So that's kind of the way to do it. Better multi-core performance, Team Red. Better all-core performance, and generally better efficiency, Team Qualcomm. But if you want better all-core performance, but better performance in multi-core, Team Red. If you want better gaming performance, graphics, we'll have to wait and see the drivers shake out a little bit. Intel's still saying they do really well there. From what I'm seeing, though, I would say Team Red here is probably where I'm going to lean to at the moment, with Lunar Lake being second place, and then Meteor Lake probably being third, and Snapdragon really not being in the running here. And then again, probably for somebody who wants something that you can get a laptop where you can plug in and run Office for 21 hours all day until your eyes want to fall out of your head. Lunar Lake looks like the SoC to beat, and we'll have to see as more reviews come out. Please wait for more reviews. There's going to be a lot more testing, a lot more reviewers that are going to be testing in different ways. So you're going to wait to see how those turn out. But for now, decent win, Intel. Yeah, you pulled it off. You beat Qualcomm in efficiency. You're pulling up really close to Apple in efficiency. You might actually beat them in some other tests where we didn't test, but pretty good wins, solid wins overall, I'd say, for Intel here. Anyway, more testing on PCWorld's channel and on PCWorld.com right here.